So today we will be finding the coefficient of friction in order to stop Baron from being pushed at a 1 meter per second velocity in 2 seconds. First we have F equals mu n, which finds the frictional force. We can plug that into F equals ma. Since the frictional force is the only measurable force at work here. Then we use N equals mg, which is the normal force, and you plug that in. And you cancel out the masses. And you divide by g. Like that.
And then to find acceleration, we're going to use the equation velocity equals v naught plus acceleration by time. And then our final velocity is going to be 0, so we'll plug in 0. And then since bear is traveling 1 meter per second, we're going to plug in 1.
For
just this hour for 10 minutes.
And for t, since it takes 2 seconds to make a final stop,
We would each be testing tomorrow, so
we'll plug in 2.
and then I can do test this year.
And then we're going to solve for a.
squirrel.
Yeah.
And negative 1 over 2 is our acceleration.
So after you have the negative 1/2 meter per second squared for your acceleration, you're going to plug it into this equation. So the coefficient of friction, just put a little s there, equals negative 1/2 times 1 over 2. So we all know that g equals negative 9.8 meters per second squared. So your coefficient of friction is, oh, I did that wrong actually before, is negative 1 over 2 times 9.8. Now if we go ahead and multiply times 2, 18. So you end up getting 19.6. So positive, by the way, 1 over 19.6 equals your coefficient due to friction. And of course, if you go ahead and use a higher initial velocity, that coefficient of friction will change, as well if, let's say, he didn't have all that fur rubbing into thermal energy. So, ta-da! So in order to find the coefficient of friction when you push Baron down a wooden floor, you first need to find a Baron. Did I find a Baron? Oh, I found you! Okay, we're gonna turn you around. Oh my goodness. Okay, ready, Baron? Okay, this is approximating 1 meter per second initial velocity. Ready? 3, 3, 2, 1. Ah! You did it! So part of the friction, the reason why there is friction is because of his fur and this floor. It causes thermal energy to go up, along with it absorbs some of the energy. So unlike in space where if you push off with an initial 1 meter per second velocity, he would keep sliding forever, but yeah, that's friction.
You're good. Wait, sorry.
And then to find acceleration, we're going to use the equation v equals v naught plus a times time. What is that?
So the general idea of this.
General idea?
So technically, if we didn't even have any friction, Baron would just keep on his constant course, sliding 1 meters per second throughout the entire interval. Jeez, have I ever told you about my roommate, the art major? Oh man, let me go into my story. Baron! Baron! No! 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 Oh! Stop it! Stop it! No! Baron, I gotta push you. This is for a project. We gotta be serious. Oh my gosh. Okay, that's good. I'll help you out.